Okay, brief summary of a longer series of more explanatory videos. Fundamental triangle. Fundamental triangle for 2 points is a triangle whose hypotenuse, okay, if we have these 2 points, the hypotenuse of the triangle is going to be run from one point to the other. The legs of the triangle are going to be parallel to the coordinate axes, one parallel to the x-axis, one parallel to the y-axis. There are 2 possible fundamental triangles for these 2 points. I've drawn them both here. One where the other terminology is these points are going to be vertices of the triangle. The vertex of a triangle is one of the corner points, so to speak. Okay, so the leg parallel to the x-axis, the horizontal leg, for this lower triangle goes through this point, and the leg parallel to the y-axis, the vertical leg, goes through this point. And right there is a fundamental triangle. For the upper triangle, the one I've drawn in green, the horizontal leg goes through this vertex and the vertical leg goes through this vertex. Either triangle is going to work. It's going to give you the same results. You just draw the one you think is going to be easier to label. So I drew the lower triangle, and then I said, okay, well, we have to choose a direction to get from this point to this point, from this vertex on the hypotenuse to this one. I choose this direction. Then I choose directions along the 2 legs that will get me from here to here. And of course, in this direction, okay? And that'll be from here to here. Okay, so if I start here, I can go this way. If I start here, I can go this way, and I still get here. The rise of this triangle is going to be the change in the y-coordinate. The rise is from here down to here. That's the change in y as y goes from 7 down to 4, and that change is 4 minus 7. When you change from one number to another, the change is the later number minus the one you started at, where you end minus where you start. You can think that through. So that's going to be 4 minus 7, or negative 3. The run is the change in the x-coordinate. We change from 3 to 12, so the run is 12 minus 3, which is 9. Run is delta x, 12 minus 3 is 9. Slope is rise over run. That's the first words you need to think of for slope, not y2 minus y1 over x2 minus x1. That's a formula. That's not an idea. Rise over run is an idea, and it's a geometric concept. It's got meaning. The other is just a formula. You don't have to have any meaning to use it. And if you don't have meanings, you don't understand meanings, and you lose track of things, and you don't do as well. And you don't develop a knowledge base, as good a knowledge base. Okay, so rise divided by run, that's delta y divided by delta x. In this case, negative 3 divided by 9 is negative 1/3. We write that slope next to the hypotenuse in a box. Okay, all the writing is outside of the triangle. In any documentation of calculations, and you want to always document your calculations, is kind of away from the triangle, because we want to have the important things in the triangle: what the rise is, what the run is, and what the slope is. Those are the 3 things that have to be labeled on the triangle. Okay, well, that's a fundamental triangle for 2 points. Now, a fundamental triangle for a function given 2 x values. Okay, well, I've chosen the basic exponential function, and I've chosen x values 1/2 and 2. So what's that mean? Well, first we graph the basic exponential function. Okay, there it is. And then we locate the points on the graph corresponding to x equals 1/2 and x equals 2. Okay, well, at x equals 2, we know that the value of the function is 4. At x equals 1/2, we don't know what the value of the function is. We can't calculate it. We're not using calculators. If we're not using calculators, what are we going to do? We're going to estimate the coordinate at that point. Well, I made an honest estimate of that coordinate. I thought it was a little less than 1.4. Okay? Now I happen to know that 2 to the 1/2 is a little more than 1.4. My estimate would have been a little less than 1.4. So estimates don't have to be totally accurate, but you make them as accurately as you can. And I debated between 1.3 and 1.4, decided that according to my graph, the value of the function at x equals 1/2 is a little closer to 1.4 than it is to 1.3. Okay? Now, that means that I didn't draw my graph all that accurately, or my eye isn't very accurate in estimating what that point is. But it turns out that 1.4 is a pretty good estimate. Okay, whether it's a good estimate or not, I can use it as a basis for estimating the slope of this fundamental triangle. So, first of all, based on this estimate, I say this point is 1/2 1.4. That's an approximation. It's not exact, it's an approximation. And it's an eyeball approximation, so it might not be a very good one. Okay, well, now that I've got the coordinates of the points, and of course I've got the 2 points, and I draw the triangle, and I put the arrows in the triangle, I do the calculations. Okay, the run, didn't have room to write it all here, run is delta x, and that's approximately 2 minus 1/2, which is 3/2. Why is that approximate? Well, it isn't approximate, it's exact. That should be equal. Okay? And that error is going to be there in the more detailed video that should be a little more, done a little more carefully, I guess. Okay, anyhow, the run is delta x, that equals 3/2. Okay? The rise is based on where's the rise? Rise is here. Got the word rise here, okay. The rise is the y-coordinate at the end of the path minus the y-coordinate at the beginning of the path, 4 minus 1.4, and that's the one that's approximate. Okay, so the rise is approximately 4 minus 1.4, 2.6. Then the slope is rise divided by run, 2.6 divided by 3/2. That's 1.7. That's labeled next to the hypotenuse. And there's the completely labeled and documented calculation of the slope of the fundamental triangle for the basic exponential function for x equals 1/2 and x equals 2. Okay, now fundamental triangle for a function on a given x interval. We're going to do the fundamental triangle for the basic reciprocal function on the interval 1/3, 2. Okay, and we're going to do it in the spirit of what we did over here by estimates, even though we could easily calculate the y values that we need. Since sometimes we've got to use estimates, especially if you have a graph that you don't have a formula for, got to use estimates to do this. And in doing estimates, you learn to look at graphs and you learn to think about what's on the graph and learn to think about meanings in a way that you don't if you follow formulas. Okay? Formulas are important, but they should summarize something you know rather than substitute for something you know. Okay, well, here's our graph. We've got the 3 points in the first quadrant for the basic reciprocal function. Now we have the function over in the third quadrant, but we didn't bother drawing it because this interval is in the first quadrant, okay? Well, the interval 1/3, 2, what do I mean by that? Well, that's the interval from here to here on the x-axis, okay? Goes from 1/3 to 2. And the fundamental triangle is going to be based on the graph point where x equals 1/3, which is here, and where x equals 2, and that's here. Now, the coordinate of this point should actually be 3 because 1 divided by 1/3 is 3. Okay? But in the spirit of doing estimates, I made an estimate that this was 2.5, not 3. Okay? So this is an approximate estimate of the coordinate corresponding to x equals 1/3. And I then say that we estimate the point 1/3, 2.5, and I actually should have labeled that a little better, so I could say, okay, that's the point 1/3, 2.5. So the rise now is from here to here. I did my arrows to get a consistent path from here to here and from the same point to the same point. So we go from 2.5 down to 1/2, because this is the 1/2 point. And I really should have labeled that point. This point is 2 1/2. So from 2.5 y coordinate here to y coordinate 1/2 here, the rise is 1/2 minus 2.5, which is -2. The run is from 1/3 to 2, which is 2 minus 1/3, which is 5/3. Then the slope is rise divided by run. That's delta y over delta x. That's approximately equal to -2 over 5/3. Approximately because the -2 came from the estimate 2.5, which we know isn't very accurate. So it's a very approximate result. And we do the arithmetic and we find that the slope is -1.2, and we do it here. I emphasize again that when you do these problems, as you're going to be assigned to do, you label everything and you show everything. And hopefully you showed a little more coherently than I did in this case.